Okay, so welcome to part 2 of the solutions. So we are going to resume on question 13. We've been doing lots of these in class, so as with all of these, we need to get all the x's on one side and all the numbers on the other side. So we are going to start, we are going to do the opposite of whatever it says. So this one says 4x plus 4, so to get rid of the plus 4, I'm going to take away 4. So I've got to remember that I need to do it on both sides, okay? So all I'm left with on this side is 4x, and then on this side I'm going to have 2x, then I'm going to take away the 4 from here, and so I will have plus 6. Okay, now I'm going to have to remove the x's from one of the sides. So obviously I've got x's and numbers on this side, so I'm going to take away these 2x. So I'm going to minus 2x from this side and minus 2x from this side. So that means all I'm left with on this side is 2x and just 6 on this side. Now this says 2 times x equals 6, so I need to do the opposite. So I'm going to divide by 2 here, so I'm left with x, and I'm going to do the same to this side, so I'm going to do 6 divided by 2 equals 3. Okay, so x equals 3. Next one, so we've got some brackets this time, so we did lots of these in class, so we're going to have to get rid of the brackets first. So if you remember, it means 2 and then times whatever's in the brackets. So we'll do 2 times 8x, which would equal 16x, and then we'll do 2 times 5, which would equal 10, and then that equals minus 22. So nice and simple again, we've just got to get rid of the number on this side and pop it onto that side, so we've got all the x's on one side and all the numbers on the other side. Okay, so if we've got a plus 10, we're going to minus 10 from both sides, so that leaves us with just 16x on this side, and if we take away 10 from minus 22, that's going to leave us down at minus 32. Now I've got 16 x's but I only want 1, so I'm going to divide by 16 on this side, and I'm going to divide by 16 on this side. So that leaves me with x on this side and minus 2 on this side. Okay, so the next one is a ratio. I don't think we've done these explicitly recently, but very similar to a fraction. So first thing we need to do is figure out how many bits they've got in total. So the first thing we're doing is add up the ratio. So 11 plus the 2 is 13. Okay, so now if I divide the total, so I've got £65, and I want to divide it into the 13 bits, okay, because that's how many bits the ratio is. So if I do 65 divided by 13, which equals 5, so now I know that 1 bit is worth 5. So now I know that 1 bit's worth 5, I want to split it into 11 bits and 2 bits. Okay, so if I do 2 times the 5, I know that this side of my ratio is going to be £10. And then if I do 11 times 5, because 5 is 1 bit, I know that's going to be this side of the ratio. So that would be 55. Okay, so the next one, exactly the same thing that we've got to do. So we're going to add up the ratio so that we know how many bits in total we're splitting it into. So we know that we want to split it into 4 bits. So then I'm going to take the number, so I've got 32. If I divide that by 4, I'm going to get £8. So I know that £8 is representative of 1 bit, and good news, I want it in 1 bit and I want 3 bits. So the 1 bit's already done for me, so that means it's £8 on this side, but then I need 3 lots of the 1 bit, so I need 3 times 8, which would be 24. So I'd have 8 on one side and 24 on the other. Okay, so 4 questions left. So the last, or these 2 are percentages, okay, so we'll be having a look at those. So 61% as a fraction in its lowest form. So we know that percentages are out of 100, so we can just take whatever number we've got as a percentage and we can pop that as a fraction and just pop it over 100. Now this is an easy one because actually 61 over 100 is its lowest form, because I can't actually make that any smaller, but with some of them you might have to simplify them, but that is it simplified. Now this is just the reverse, so 49 over 100 as a percentage. This is a nice easy one because a percentage is already out of 100, so if you've got a fraction that's already over 100, it's just that top number, is it represented as a fraction. So that one would just be 49%. Okay, so the last 2 are kind of a little bit more difficult because we haven't really gone through this in class at all. But when it says find the gradient of the line, it's basically imagining a line on a graph that would be like this. And the gradient is essentially kind of how steep the line is, so how steep it is in terms of this way. Now, when it's in a form of y equals something x plus something, the gradient is always the bit behind the x. So in this one, the gradient is 0.5, and in this one, the gradient is -2. So if it's positive, the line will go this way, and in this case, if it's negative, it will go this way, with obviously that being the x-axis and that being the y-axis. But yeah, for now, the gradient is just the number behind the x. But we'll look into that in more detail when we do our next topic. So please make sure you've marked these in your purple pen or any other acceptable colour, and I hope you're all well.